had to go through and do the amplitude, the frequency, the period. Remember, A is your amplitude, B is your frequency. How many complete cycles in 2 pi? The normal is 1. 2, frequency of 2, we have 2 curves in 2 pi. 2 curves in 360. 3 curves in 360. Kind of think it out rather than worry about, oh, 2 pi over b. I got to divide this out. Think it out instead. Your period is the same. That's this, yeah, you have to know the 2 pi over 3 over b, but if you kind of think about it, and I have 2 in 360, and I say 360 divided by 2, every 180, there's your period, pi, 2 pi over 2. So kind of think this out and make it make sense. The amplitude was 3. Remember, your amplitude is always positive. If it starts the other way, it was a reflection, not a negative amplitude. Okay. These guys, you just had to pull out your A and your B and find your period. God bless you. Now, when you see this, x over 2, pull the fraction out. It's the same as 1/2 x. So if you have half of your curve in 2 pi, how long is it going to take you to complete a full curve? 4 pi. So 2 pi divided by 1/2. Says keep, change, flip it over. Now don't fall into that trap of giving me 1 pi. Because half of my cycle in 2 pi, the other half in the other 2 pi. Amplitude, that's the guy out in the front. You can do your frequency with a pi. Same process. If it takes you, you want to do pi cycles, just do the same thing. I don't really give you those because we would have to change your degrees back to radians. That's the only way to really do those is in radians. But that you know the same concept is there. Okay, this negative out in front, this is a reflection. It is not part of your amplitude. Your amplitude is always absolute value. It's always positive. So your amplitude is 2, your frequency is 1, that's your standard one. 1 curve in 2 pi. That's your period. Good? Yes. For those of you that didn't do it, are you seeing it? Okay, again, this guy, it's easier if you pull this out. Make it like this, 2/3 x. That means in 2 pi, you get 2/3 of the curve. So you need to make a complete cycle. So the same thing, 360 divided by 2/3. That would work. 2 pi divided by 2/3. That would work. You need another third of your curve to get there. Another third of that. So if you kind of think about it, there's your 3 pi. Number 29, they gave you 2 graphs. If your graph starts at the top, it's a cosine. If it starts at the 0, it's a sine. Unless it's a phase shift. But I won't give you a phase shift because then you wouldn't know if it was a sine or a cosine. So what did it do here? It did it good, 1 up. So instead of starting at 1, it went to 2. This is called a vertical stretch when your amplitude changes. If it was a half, it would be a vertical shrink. Everything else stayed the same. 30, it took a cosine curve. That's the one in black, the dark one. Then it changed your frequency. Instead of 1 curve in 2 pi, I want 2 curves in 2 pi. So every 180, I have to complete a cosine curve. So from here, there's 1, there's 2. 2 curves in 2 pi. This is called a horizontal shrink. Instead of stretching it like this, it's pushing it together like an accordion. It shrunk, what it did was it shrunk the period. It didn't exactly shrink the curve, it made more of them because it shrunk your period for your curve. It changed your cycle, it took half the cycle, half the period. That one used, number 31 used a sine curve, and it translated this. From here, if you notice, to this point right here. This is at 4 pi. So half of 4 pi is at 2 pi. Keep an eye on where they're going with this. So it moved it from here to here. It moved it 1 pi. See it? So we had a translation, pi units to the right. 180 degrees to the right. Because this was set up in 4 pi. The Regents also like to do that to your graph problems. Instead of going from 0 to 2 pi, they either went from 0 to pi or 0 to 4 pi, and they try to trick you that way. So this one does kind of like the same thing. Here's a translation, a shift. We took everything and moved it up 2 units. Look from here, up 2 units, find your resting point. I like to look at the resting point because then you can see where your x-axis shifted. Sometimes it's harder to see in the parts of the curve. So you did a vertical shift up 2. Notice what they did here? You did a complete cycle in 4 pi. So our frequency is how many cycles you complete in 2 pi. So 1/2. 1/2 of it was completed in 2 pi. You kind of have to think this out. Okay, these were horizontal shifts over. It works the same as your quadratics, your squaring, your cubing, all of them. We shifted the opposite way, so you're going to shift right, pi over 2, and that made your sine curve. So they were the same curve. You shifted your cosine curve over to the right. Just fell on top of your sine curve. And those are nice to put in your calculator as well. If you're going to put this in your calculator and you use pi over 2, you have to use radians. Then you have to zoom 7 all over again. But instead, just put 90. Leave it as degrees. Just say 90. Shift it 90 degrees. I kind of am partial to graphing in degrees just because when you look at your table, you can recognize it. The radians change to decimals. It's harder. This guy, what was that? Oh, you didn't have that one? Which one did you have? 44. 43? Okay. 43. We changed your amplitude by a factor of 3. Nothing else changed. Okay. 45, did I give you 45? You changed your amplitude by a factor of 1/4. That's a vertical shrink. Number 47, we changed the period. You now did half of your curve in 2 pi, so it took you 4 pi to do the rest. My curves look curved. So there's your horizontal stretch. And I didn't do this part with you, so we're going to do this part now in 49. You did a shift to the right, 45 degrees, pi over 4. Now, when you start your sine curve, here's your sine curve. If we're going to start it over here, it's going to do the same thing, but 45 degrees over. So if we want to know where does the full cycle go from, it goes from 45 to here, plus 360. This would be 405. So it goes from 45 to 405 degrees-wise. Just think degrees for a minute, because it's got to take 360 to complete a degree. So what we do here instead is easier than that. We take this, your normal sine curve, went from 0 to 2 pi. We take whatever is in here, set it equal to 0, because that's going to be where you start, pi over 4, and we set it equal to 2 pi, because I need to complete this in 2 pi. So where am I going to end? At 9 pi over 4, which makes sense. Because what is my pi over 4 is double? 8 pi over 4, right? And what is 1 more pi over 4? 9 pi over 4. So does that make sense when you think of radians? It does. So if I said this, my sign, I want to go the opposite direction. So where is my cycle going to begin? Which way is this translation going? To the left, pi over 4 units, right? So 45, so it's going to start at the negative pi over 4. I want you to think, I need 2 cycles. I need 8 pi over 4 to get a complete cycle. But I shifted everything to the left. So where's my end going to be? Positive pi over 4 would just give me part of it. I need to go 2 pi. Okay, so I want it in radians. Normally you would go from 0 to 2 pi. If I'm going to convert this to fourths, this is still going to be 0 over here. But how many fourths is this going to be? When I doubled your 4, what is that going to be? 8 pi over 4, right? I'm going to go from 0 to 8 pi over 4. That's 2 pi, right? If I move it left, 1 pi over 4, where will my cycle stop? 7 pi over 4. And if I do it the other way, I'll say x plus pi over 4 equals 0. So x is equal to negative pi over 4. Oh, that's where I start. I'm going to say x plus pi over 4 equals 2 pi, which is the same as 8 pi over 4. I want to keep the same denominators. I subtract 1 pi over 4. And I get x stops at 7 pi over 4. So my cycle now will go from negative pi over 4 to 7 pi over 4. I just moved it over. A translation is a slide. I just split it. It still takes 2 pi to finish. So if you take whatever's here, set it to 0. You take whatever's here, set it to double, 8 pi over 4, or 2 pi. You'd have to convert 2 pi to your fraction of 4. Okay? I didn't do that part yesterday. I think I just gave you 51. It had a negative, that's a reflection. That's not your amplitude. Your amplitude is plain old 8. It's the absolute value. So I have a vertical stretch, and I have a shift. Pi, which way? To the left. Now, think this out before you look at this. Here's my cosine curve. I'm going to shift this. Pi. Here's all my pieces. That's stuck over there somewhere. I'm going to shift it over here and start over here. So if I shift it, I have to make 2 pi to finish this, right? If this is going to start here at negative pi, where is it going to end? Pi. It needs 2 pi, doesn't it? 1 pi, 2 pi. Doesn't a complete cycle take 2 pi? So if I set this equal to 0, and I set this equal to 2 pi, I should get the starting point and the ending point of a full cycle. Granted, your curve is continuous, but if we're going to go like from 0 to 2 pi, we need to back this up a little bit. Back this up pi units to the left. Okay? Okay. They're just not continuous. So we're going to take a look at where their discontinuities happen. Where are they not, where we cannot use a tangent? So let's take a look at your 0. At 0, remember your tangent is y over x. So at the 0, look at your quadrant angles. We're going to take 0 divided by 1. 0, right? We can divide 0 divided by 1. We just can't divide the other way. At 90, we have 1 divided by 0. Can't do. undefined. That gives us an asymptote. We can never use 90. If you put in your calc, tangent 90, undefined. It says, I'm not sure what it says, can't divide by 0. Does it say can't divide by 0? Can't divide by 0? Okay. At 180, I'm 0 divided by negative 1. So what is that? 0. At 270, I'm negative 1 divided by 0. Can't do it. And back here, I'm at the 0. So I've got these asymptotes where I can't use a tangent. Now to help us, we're going to find 45. So at the 45, this is, well, I'm on the unit circle. What's your tangent at 45? What's your tangent at 45? 1, right? Is the side over side, which has to be the same always. So your tangent of 45, half of this guy, is at 1. I'm just going to use this for a reference. Your tangent in quadrant 1 is positive. Your tangent in quadrant 2 is negative. Your tangent in quadrant 3, positive. I'm only using the 45s in all these quadrants. And in quadrant 4, your tangent is negative. Your tangent curve and the negative 45 will be down here. It's going to look like this. It is a function, but it's not continuous. It's going to keep going like this. It's a function, but it's not continuous. Okay? Now we need to define the domain and the range of your tangent curve. Let's go to the range for a second. What's the range of this curve? Good. Negative infinity to infinity. These guys continue and go on forever, right? Now, let's work on your domain. Your domain says it looks like I can use a lot of these numbers. I can use all the reals except what ones can I not use? Which ones are getting the asymptotes? 90, so let's call that pi over 2. What other ones? 3 pi over 2. Following this pattern, what would be the next one that I couldn't use? 1, 3, 5 pi over 2. Negative 1 pi over 2. Negative 3 pi over 2. Negative 5 pi over 2. So it looks like there's multiples of pi over 2. So I'm going to say except n pi over 2, where n is an odd integer. An odd integer meaning if it's 1, or 3, or 5, or 7, or negative 7, negative 9, negative 11. I can use any number except the multiples of pi over 2 where it's odd. 90, 270. No, but it's easier in the radians because 1 pi over 2, 3 pi over 2, 5 pi over 2. Alright, so I've got a domain and a range for my tangent curve. Okay, it's also on here. See it on here on the sheet that I gave you? This kind of sums up what we looked at. There's your tangent curve. It looks much prettier than mine. Here's your domain and range. You have to qualify that to say n is an odd integer. Okay, hang with me. A cotangent. So let's walk through your cotangent. Cotangent is x over y. It's the reciprocal function of tangent. So at the 0, if I say 1 divided by 0, can I do that? No. This is an asymptote here. Where else do you think there would be an asymptote? At the where? All the even ones of pi over 2. So 1 pi over 2, well, 2 pi over 2, which is the same as pi, right? So at the pi, 3 pi over 2 would work, 4 pi over 2, which would be at your 2 pi. Okay? All of these quadrants over here are not, if this one's not going to work, this one's not going to work. Isn't the 0 and the 1 in the same position? Okay? So these guys will be where my zeros come through. Okay? We'll just do a couple on the side. Now, let's take the 45 again. Tangent of 45 is 1. In quadrant 1, it's positive. So at the 45, I'm just going to make a 1. In quadrant 2, it's negative. So you see your cotangent go this way. All your cotangents go this way. See it? Good so far? What's the range for this guy? All our numbers, that's the same as your tangent. Now, your domain says all real except when x is, tell me which ones you see that we can't use. Pi, 2 pi, what do you think comes next? This is 1 pi, 2 pi, 3 pi, 4 pi, oh, n pi, any number that's an integer, where n is an integer, not an odd, not an even. The even we were looking at the pi over 2's to say even, but they all reduce to a pi, so we're going to keep this one with pi. So if I do negative 1, negative 2, I can't use those either, okay? So we have to have a little qualifier in here. And that is also on your sheet for cotangent. See your cotangent curve? I thought this would be a good visual after we go through them all. Alright, let's hit one of your other reciprocals. Now in Algebra 2, we hit these really, really briefly to hit your reciprocals and graphing them. I find graphing them is much easier to graph their original function and then put the reciprocal on top of that. So cosecant is the reciprocal of which one? Sine. So whatever other attributes are here, I'm going to use the same thing. I'm just going to graph my sine curve. Here, 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 here. So I want you to see a pattern here. Now watch what happens. At the 0, if I have to take the reciprocal of 0, 0 over 1, if I turn it upside down, reciprocal, 1 over 0. Can I divide 1 divided by 0? No. This guy's getting an asymptote. All your zeros on your x-axis, it's 0 over 1. If I take the reciprocal, it's 1 over 0. All of these guys on the x-axis will be an asymptote. Because if I take 0 over 1 and I take the reciprocal, it's 1 over 0. Can't do. Now, here's your easiest way. 1 over 1, when I flip it, is 1. 1 over negative 1, negative 1. These guys are where I start making my curve. They go up. Because it's everything up my curve. So this is how you draw your reciprocals. Okay? And again, down here, you draw your reciprocals. You start with your basic curve. Find your asymptotes. Your asymptotes are where they cross the x-axis. Because if you flip 0 over 1, you get undefined. And it's the opposite of what my sine needs to be. So let's take a look at your domain. Your domain says real numbers except, watch what happens. You can't use the 0, the 1 pi, the 2 pi, the 3 pi, the 4 pi, the negative 1. So n pi, where n is an integer, not a negative, but any integer. We say integer because we can't put like a 1/2 in here because that screws us up. But we can use negatives. 0 is an integer. I can put 0. 0 pi gives me 0. Okay? So get used to seeing these. I think it's on the back of this sheet. Those reciprocals are on the back. Now, if you want to like sketch in your original sine and cosine curve, I think it makes more sense. To be honest, that's how I do it too. I always sketch my original curve in. And the last one is the secant, which is the reciprocal of which one? Cosine. So I'm going to start here, just map out my cosine curve, and just draw out my cosine curve. Okay? Again, at my zeros where it crosses the x-axis, well, and this guy's 0 right here at the pi over 2, and this is 0, the negative pi over 2. 0 over 1, if I take a reciprocal, is 1 over 0. All the places where it crosses your x-axis is now an asymptote. After we do this one, you're going to see what these patterns are. And they come off of the curves. Oh, I forgot to do the range for the other one. When we do the range for this one, you'll see. The other one has the same range. Now, this domain says all real numbers except when x, I notice, is 1 pi over 2, 3 pi over 2, 5 pi over 2. Where did we see that before? With the tangent. So n pi over 2, where n is what? A negative, an odd integer. Where n is an odd integer. I can't use the 1 pi over 2, the 3 pi over 2. The 2 pi over 2 is pi. I can use 2 pi over 2, which is pi. Now, on these guys, your range is exactly the opposite of your sine. Your sine went from negative 1 to 1. Your secant and your cosecant go completely the opposite. They go from negative infinity and stop at negative 1. Or they go from 1 to infinity. That's 1. 1 to infinity. And we can use 1, can't we? Because the reciprocal of 1 over 1 is 1. So that's the only point that these two curves have in common. It's a lot to look at. Okay? Now, we can apply this knowledge to any of your curves. If I look at the secant of 2x, I'm going to first do my cosine of 2x. Give me 2 minutes on this, guys. I'm going to first do the same curve for my cosine of 2x. So, and I'll show you in a minute how we change this. So your cosine curve has to complete 2 and 2 pi. So every pi, it's going to complete 1. So my cosine curve is going to be here, 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 here. Yeah. But just your basic cosine curve. Okay? Your basic cosine curve. I could just do the 1/2 on it. I was going to do 2 sets, but you want me to do the 1/2? For time, let's go to 1/2. Okay. I was going to do one step at a time, your parent curve, but we can go to one step. Make life easy. Okay, we just jumped to your one transformation already. We did the 1/2. And then you're going to do it again. It all works off your parent graph of your regular standard cosine curve. Now, if it comes on the side, it still follows that anytime at the zeros, you're going to get an asymptote. You're going to get an asymptote at those zeros. And now, your range changed because your range changed for your original cosine curve. I was going to change the range on the original, but we've got it all at once. So your range, give me 1 second, guys, is from negative infinity to negative 1/2, and from 1/2 to infinity. Now, your domain changes. Your original domain of your secant curve. Pick up the chart. Your secant curve. It's on the back. What's your original domain set? All real numbers, except where n is any integer, right? Now, this is how you do this. You take this guy x, and instead of x now, it's 2x. You set 2x equal to n pi, and you solve for x. Divide by 2. But you still keep this, where n is any integer. Now let's see if that's true. At the n pi over 2. Oh, isn't that half? At the n pi, whoops. I did something wrong. I didn't take this. I'm sorry, I took the cosecant. Sorry, give me 1 second. I took the cosecant, not the secant. The secant says x equals n pi over 2, where n is odd. Take this x value. Give me 1 second. Set this equal to this. Cross multiply and divide by 4.
Good afternoon. Some important announcements. Students, all afternoon and evening activities have been canceled for today. All students are to leave the building at dismissal